Hi there. So this is my solution for the generator network. So like I was saying before, we're basically building the same, kind of overall network structure as before, except now our generator is a convolutional network, or more accurately, a transposed convolutional network. So here is how I built the generator. So first, I just passed in. So we passed in this tensor z. So this is our noise vector that we're using to generate images. And so I first connected this to a fully connected layer. So this is tf.layers.dense. And I gave it a size 4 times 4 times 512. So basically, kind of what they did here, they made it 4 by 4 times 1024. But since our final layer is 32 by 32 instead of 64 by 64, I basically I took out one of these convolutional layers. So I'm just using this one and then 2 convolutional layers and then this final convolutional layer. So what that means is that I basically started with 512 filters here and then 256 and then 128 and it ended with this guy where it's 32 by 32 by 3. So here I just created my fully connected layer. It's with a size of 4 times 4 times 512, and then I reshaped it into this guy with 4 by 4 by 512, and then added batch normalization and our leaky ReLU. So now our layer is 4 by 4 by 512, and then basically send this to another transposed convolution. So this one with 256 filters and set the strides to 2 and with a 5 by 5 kernel. And again, batch normalization and leaky ReLU. And then so now it's the layer size is 8 by 8 by 256. Do it again, same deal. So now we have a depth of 128, kernel size 5 by 5, strides of 2, and then batch normalization and leaky ReLU. So now we have 16 by 16 by 128. And then finally connect this to our output layer. So where we have 3 output dimensions is 3 in this case for our images. And then, so basically every time we do strides of 2, we increase it we double the width and the height. So now we're going from 16 by 16 by 128 to 32 by 32 by 3. So we use that layer as our logits and pass it through the tanh function to get our output. Okay, so next up, we're going to be looking at the discriminator.